Aromatic compounds are a class of organic compounds that smell really strong, hence the name aromatic. But don't confuse the term aromatic with good smelling, because some of these smell pretty nasty. Aromatic compounds are compounds that are hydrocarbons, and they contain alternating double bonds, right? One kind, or I guess one subclass of an aromatic compound, which is the one that we focus on in Chemistry 11, are the benzenes. Benzene is simply a cyclohexene with 3 double bonds. So if we draw our cyclohexene structure, like so, 6 carbons all around, and this is a benzene, an aromatic compound. It has alternating double bonds. We have a single, double, single, double, single, and double. So the carbon backbone has alternating double bonds, and it looks something like this. How many hydrogens are we expected to have on this structure? Remember that each carbon can only have 4 bonds maximum, and this gives us just 1 hydrogen per carbon, like so. This particular aromatic compound is called a benzene. If we were to draw the condensed structure, remember that condensed structures simply just take away the bonds between C's and H's, it would look something like this. On the left here, sometimes you'll see C's being ahead of the H's, just to show that the bonds are between C's and not the H's. Okay, and let's put in our alternating double bonds. A line diagram is fairly simple. It looks like a hexagon, and put in those doubles alternating like so. I'm going to move this to the side a little bit. Okay. A special feature of aromatic compounds is that the double bonds in the compound are said to have resonance. Resonance is a concept that we first learned about back in Unit 8 when we talked about molecules like CO3 2-, if you recall that. And we said that the double bond actually resonates, or it moves around from each C and O. So this double actually moves round and round and round, and hence we drew 3 structures for that compound. Resonance also occurs in aromatic compounds. What happens, need a different pen here, is that these electrons that make up the double in the middle, they can actually move from carbon to carbon. So if that double bond moves over there, that kicks out this double bond, which moves down there, which kicks out the other double bond, moving it there. So we get a resonance structure where the other benzene, there we go, where the other benzene looks like that. To show resonance, sometimes we abbreviate or shorthand draw that resonance as if it could get any easier, right? The symbol is a circle. So a circle within a hexagonal ring means that there are alternating double bonds within, and they are moving around and around, which is a phenomenon called resonance. We say that the electrons are delocalized, which means that they're not permanently fixed anywhere. And because of this resonance, these molecules are highly, highly stable, which means they're unreactive for the most part, unless you do some serious chemical reaction with it, like combustion, high temperature burning. Okay. So a benzene is just an aromatic compound that is a cyclohexane in nature. There are other aromatic compounds out there, as long as you have alternating double bonds. I'm just going to give you 2 examples. 2 examples that you may have heard of. Probably not, what am I kidding here, right? 2 examples that you can relate to. That's a better word for it. Here we have a conjoined twin right there. 2 benzene rings stuck together in the middle. This compound is called naphthalene, or naph as we call it, naphthalene, and it's that compound that gives mothballs its characteristic mothball smell. Now these rings can be conjoined multiple times, so here's another one. Okay, a triple fused ring here. Again, it's double, single, double, double, single, double, double, single, double. This one here is called anthracene. Not one that you would have heard of, but it's in a lot of dyes. In particular, it's in red dye. Doesn't smell good. And it's actually, I think, derived or used in coal tar. Well, not a very pleasant compound. Just before we start naming these compounds, I'm going to talk a little bit about their 3D structure. Namely, how there is none. Benzenes, because each carbon has 3 attachments on it, each carbon is trigonoplanar. And if you put 6 trigonoplanar structures side by side, you get one large trigonoplanar structure almost. And so the benzene molecule actually sits flat. It sits flat and it's quite 2D. Okay? Compare that with a cyclohexane structure. I have a slightly different model here, but it's pretty good. Cyclohexanes, where there's single bonds all around, each carbon has 4 attachments, so they're all tetrahedral. If you stack 6 tetrahedrals side by side, you don't get a structure that sits flat on the surface. It actually looks quite jagged, like so. We have fancy names for these structures. This is called boat, because we're creative people like that. And then the other conformation that these guys can have is the long chair or chair structure. Okay, so benzenes, flat 2D, cyclohexanes, jagged and so not 2D. Alright, on to naming. Naming benzenes is actually rather straightforward. Let's do an example. Okay, here we have a benzene ring with 1 branch. Just like any cyclic structure, when you have 1 branch, it's automatically assigned number 1, and we don't write 1 because that would be redundant. The branch is a methyl in this picture here, so it's called methyl. And now the root word or the parent word for benzenes is just benzenes. Can't get any easier than that. Methyl benzene. Let's take a look at something with more than 1 branch. If you remember, this is a compound that we first saw back in Unit 3, I believe, a long time ago, when we did the heating and melting curve of a pure substance. You guys remember when we had those tubes of that clear, colorless crystal, and it melted at, I think, 70 something? Can't remember. Anyways, the whole room smelled like mothballs because it was an aromatic compound. Back then, we called it the para-dichlorobenzene lab, and now you know what dichlorobenzene refers to. Okay, so one of these chlorines is going to be 1. The shortest path, well, it's symmetrical, so let's just take a path around here. We got 1, 4, dichlorobenzene. Okay. Why is it called para-dichlorobenzene? That's good. Good question. I'm glad you asked. Turns out in organic chemistry, as you advance, we start coming up with these cute little nicknames for certain patterns of branches. In university, you get introduced to para, which means branches at 1 and 4, ortho and meta, which is 1 and 3, and 1 and 2. We don't worry about that in chemistry 11 because that's too many names to throw at you guys all at once. So 1,4 dichlorobenzene. But later on, you will discover that the other name for this compound is para-dichlorobenzene. Para meaning 1,4. Alright, next example. Here we go. Remember that you can feel free to use the circle symbol if you don't want to draw the alternating doubles. There we go. Okay. Shortest number set, or lowest number set, is probably going to be 1, 2, and 4. 1 being here, 2 and 4 is over there. Remember that bromine certainly B will go first. We usually try to assign that priority if possible. So this is going to be 1, 4 di-bromo 2 methyl benzene. There you go. Okay. So benzenes, the benzene ring is considered the parent chain, the longest chain, but not always the case. Sometimes you will see a structure that has a benzene ring, but is problematic to name. I'll give you a second and see if you can figure out why these things are problematic to name. There's another one here. Let's give you 2 more. And as you copy these down, hopefully you're thinking about why these particular compounds are tough to name. And last one here. Alright, these guys are hard to name because if we were to consider the benzene ring as the parent or the main chain, the main constituent, then we have to name the branch that comes off it. And the question is, well, how do we name a branch that's got its own branches? We can't. So we have a second naming system for such structures. When you cannot name a branch on a benzene, we will change our perspective and we will consider the benzene ring as the branch. So on this first structure here, the longest parent chain is 2, 3, 4, 5 carbons long. This is a pentane chain, and we're going to consider the benzene ring as a branch. Okay. Now, when a benzene ring is a branch, the branch name is called phenyl. Why it's called phenyl and not something more resembling benzene? Your guess is as good as mine. Alright, so we got methyl groups in the phenyl group. M comes before P, so we are going to name the methyl groups first. We have 2, 3 dimethyl. 1. Looks like my pen running out of batteries here. 1 phenyl, and then we finish it with pentane. Okay. Next one. Again, we have a benzene ring, but the branch coming off it has a branch of its own, so we are going to treat the benzene ring as a branch and look for a longest alkane chain. So it looks like our longest chain is 1, 2, 4 carbons long. Again, we try to keep the number set as low as possible. So we're going to have 1 here, 2, 3, and 4. M comes before P, so this is 2 methyl, 1 phenyl, and this is butane. Okay. Next, we have something looking a little bizarre here. Our longest chain is going to be the one going straight across. Let's try to give them the lowest number set. We can go 1, 2, 3, 4, 5, 6, 7, and 8. So we could have 3, 5, and 6 for our number set. Our other option is to go from the left. It's probably better. 1, 2, 3, 4, 5, 6, 7, and 8. And that gives us 3, 4, and 6, which is better than we had before. Alright, bromo goes first because it's a B. 3, bromo. 6, ethyl. Phenyl ring is on 4. Phenyl. My pen is really running the batteries here. For phenyl, octane. And our last one. Our last one's tricky. Remember that you have to find the longest continuous chain. The longest continuous chain happens to be 1, 2, 3, 4, 5, and 6. Whoa, it curves up. That's exciting. Okay, so if we do that, we get 2 and 4 for our number set. If you went the other way, you would have gotten 3 and something else. So we're going to go with 2 and 4. First one that goes is ethyl. 4 ethyl. Next, nope, I'm sorry, there's no ethyl. Oh, silly me. It's going to be 2, 4 dimethyl. Where's the next one? 4 phenyl. Hexane. Alright, so that's benzenes. Just as a final thought, just a tidbit, there actually is a branch called a benzyl branch, which is kind of like benzene. And I'll just do a final little note here, just to show you what I mean by that, so you can figure this out. If I have a branch that looks like this is called a phenyl branch. If I had a branch that looks like this, that is called a benzyl branch. But that's just for your interest. Just in case you're wondering why the branch is called phenyl, I actually don't know. But benzyl branch, yeah. I don't know if that makes it better for you. But there you go. Alright. Go out.